Yeah, back here. Share that. Yeah, now back here with the BFS sharing first, which we'll going to see. Now, I'll take a first graph. Now I'll go with first BFS, right? Right, BFS. In a BFS, first I'll take a graph. A, B, C, right? That's what we have did. D, E, F. Right, and I remember the things, that is 2, 3, 1. Remaining thing you tell me. B to D, B to D. Anybody? 5. C to E, 3. 3 or 2? 3 or 2? C to E. Huh? Hello? 2. Next, D to E. 1. D to F. 1. E to F. 3. Yeah, right. Now we will take first this one. Yeah, one thing I want to tell you, why for BFS we need the cost? We don't need, right? No? Hello? For DFS we are not taken cost, am I right? Yes, see, I've forgotten. I'm confusing with Kruskal. You know, you don't need a cost, just a graph is enough for us. Yeah, just graph is enough. That means take off these values. You don't want that values. I'll rewrite the graph which you can see. Now, how you can do this? Means traverse. Assume the source vertex is A. Assume the source vertex is A, and we will take one Q. Initially, the Q. Q will be an empty Q. Right. Now what first we are going to do? First we will take A and make the visit. Initially it will be 0 for all the things. Just for 1 minute. Sir, class allide sir.
Class yes. Police station ಗೆ ಅವರೇ FIR ಹಾಕ್ಬಿಟ್ರೆ
Yes sir.
ಮಾಡ್ತಾರೆ ಒಳಗೆ ಓದ್ಬರೋಣ ನಾನು ಓದ್ಬರ್ತಾನೆ
ಅಲ್ಲ ಸರ್, ಕ್ಲಾಸ್ ಇದೆ ಸರ್, ಕ್ಲಾಸಲ್ಲಿ ಇದೆ.
ಎಷ್ಟೊತ್ತಾಗುತ್ತೆ?
1 hour ಸರ್.
ಬೇರೆ ಬಿಟ್ಟು ಬನ್ನಿ, ಬಂದ್ಬಿಡೋಣ, ಅಲ್ಲಿರೋಂತ ಆಲ್ರೆಡಿ.
ಹೌದಾ ಸರ್? ಸರಿ ಸರ್, ಬಂದರೆ ಸರ್.
ಸಂತೋಷ.
Just 2 minutes, be on a line. Just 5 minutes. ಸರ್ ಒಂದು ಹಾಫ್ ಅನ್ ಅವರ್ ಸರ್, ಯಾರೂ ಇಲ್ಲ, ಆನ್ಲೈನ್ ಕ್ಲಾಸ್ ಅಲ್ವಾ, ಮುಗಿಸ್ಬಿಟ್ಟು ಬಂದ್ಬಿಡಲ ಸರ್, ಸ್ಟಾರ್ಟ್ ಮಾಡಿಬಿಟ್ಟಿದ್ದೀನಿ ಅದಕ್ಕೆ. ಹಾಫ್ ಅನ್ ಅವರ್ ಸರ್ ಅಷ್ಟೇ, ಪ್ಲೀಸ್ ಸರ್. ಓಕೆ. Yeah, now back here with a lesson. As we have started with tracing of this particular the BFS algorithm. Now coming to the starting, we'll assume the source vertex as an A, and initially all other vertices, first what we have to do, and we'll make that visited as a 0, and whatever the 0 values will be there, we will make that as a large value, that is a infinite value. That is common here also. Now what we have to do here, first thing, we'll start with A and we'll see what are the adjacents of A first according to the symmetric format, and that's alphabetical format it will come. For example, I will tell you like this. Now if I take A, A is already visited, first we should make that as 1, right? Then what we have to do, now we should start with the adjacents of A and B. Now for B and C. Now for A, two adjacent vertices are there, that is B and C. Now first what I will do, I will consider B first. So why? Because in alphabetical order, in symmetric format, we should consider always only that set. In the computers also, after 0th vertex, one vertex will come in a for loop wherever is there. Like that, we will also consider like that. Now from 1, what is the next adjacent vertex? That will be B. Now what I will do, I will make B. I will transfer enqueue that B into the Q, and then I will go to the B and I will make the visit of B as 1. Now from B we will check which are the adjacents of B and means A and C. Now we will check that particular thing. Other 1 minute, just 1 minute. Yeah, right. Now from A, what is the other, we'll go to the B. Now from A we should complete first A everything. Now coming to the A, now what is the another one adjacent vertex is there? The another one adjacent vertex is C. So now what you have to do, from A you will come to C. Note the point, from A you will come to C. Now what you have to do, you make C into the Q, and you come to the push that to the C. Now what you have to do, both the adjacents has been enqueued into the Q. Now what you have to do, you should take out the first adjacent from the Q. That is important, take out, that is B. Now what from B you have to do, you make first B as a visit 1. Now I have taken out B from the Q and I have made B as a visit 1, everyone. Now what the next thing is there, from B how many adjacents are there, that you have to check. From B, A is the first adjacent which is already visited is 1, we have checked it. Now you can see from the another one is according to the symmetric, the C is there. Now the visit of C is 0, but the C is already there in a Q. So already there in a Q means once the vertex is already there in a Q means you can't enter another time. So this you have to make a note. So then what you have to do, what is another adjacent from B, you have to take that. The another adjacent from B is D. Now transfer enqueued D to the Q. Right. So after enqueuing D to the Q, what you have to do? You have to check whether all the adjacents has been over. Yes, all the adjacents of B has been over. A, C and D. No other adjacents are there. Okay. Next, in a Q, what is the first element is there? You have to delete that. So what is the first element? Here it is C. Now you take C. Now make C as 1. After making C as 1, what you have to do? Then you are, from C, you should check how many adjacents are there. From C, as usual, the adjacents are A, B and E. Now A already visited, it's 1. B already visited, it's 1. E is there which is not visited, the value is 0. Now what we have to do, we have to enqueue E into the Q. Am I right? After enqueuing E into the queue, what you have to do? You have to see any other adjacents are there. No, for C, no adjacents are there. Then what you have to do? You have to take out the first element of the queue. In a queue, you delete. That means D you take. Now you make a visit of D as 1. From D, you check the adjacencies. From D, the adjacencies are B, E and F. Am I right? Now you check for B. B is already 1. No need to touch at all. Come to next E. E is already there in a queue. So we can't put the same element twice into the queue. Now come to the F. Now you can see F visit is 0. Then you add F to the queue. Now what you have to do? All adjacents are over. Now in a queue, which is the first element? E. You take the E as a first element. Now what you have to do? You make E visit as 1. Now for E, what are the adjacencies are there? You check. For E, the adjacencies are C, already visited. Next D, already visited. F, not visited, but F is there already in a queue. So no need to put again. Now you remove that. Now after removing this, now you check in a queue which is there. F. For F, no adjacencies are adjacencies are there. D and E, which is D is already visited, E is already visited. Am I right? So then F also we have visited. Make F as visited as 1. Now no elements are there in a queue. That means you have visited all the vertices of the graph. That is how you have visited. You have visited starting from A, you have gone to B, then you came to C, from C you gone to D, then you gone to E, then from am I right? E, right. From after visiting, taking a E, so last one is F. You gone to F. Now, in this way, you have traversed the given graph. Sorry, this is right. Are you understood? Are you understood? I will take another one graph. I will take another one graph. You will understand clearly. Now, here no stoppings will be there for you. Right. I'll take another one graph. Now you tell me one graph. You tell me one graph. I'll take it as A, B, C, D, E, F, right? And let it be G. Almost all done. Right. Now I will start. I will take one cube. Right, in exam how you have to do, I will do like that. In exam you have to write, consider a graph G for example. So G you have to write. After taking G, consider a Q which is empty, where you have to write that, where F is equal to 0 and R is equal to -1. Are you considering? Everyone getting? Yes. Right. Now this is step number 1. What step number 2 you have to do? Take a step number 2. In step number 2, consider they may give any source vertex in exam, or otherwise you can consider any of the vertex. Do you want to consider any other vertex other than A? Everybody? C. Okay. I will consider C as source vertex. Right, everyone, are you getting? Consider C as source vertex. Make visit of C as 1. In first step, in one side you should write initialize all vertices to visit to 0. I lost of disturbance for me. Just a minute. I will switch off it. Now, are you getting? Initialize all vertices visit to 0. That will comes in the first step. In exam you have to write like that. Next, consider C as a source vertex. Make a visit of C as 1. Right? Now you consider C here. And visit will be 1. And you consider Q again here. In exam you have to write like that. Now, below you have to write from C, the adjacent vertices are now you should start with symmetrically. A, B is also A, B, C is already there. Next D. You can consider C also if you want. Means correct flow you will get. A, B, C, then D. What else is there? E. That's it. Correct, no? Now, from C, the adjacent vertices are A, B, C, D, E. Right? Everyone. Now, consider the first adjacent A. NQ into the Q. Like that you have to write. Now, what you have to do? You have to NQ. You have to NQ. That means you should take a Q here again. You should transfer A here. Now what you have to show? Now you have to show R as 0, F as here. Are you getting everyone? Everyone getting? If you're not getting, you can stop me and ask me. Right. Now coming to the next adjacent from the C is B. Now the visit of B is 0. You have to check the condition. That is very much important. The visit of B is 0. That means B is not yet visited and B is not already there in a queue. For A also same thing. Visit to A, before transferring A to the queue, what you have to do? You have to write here. The visit of A is 0. Right? No vertex in Q. NQ A. Right? Then this will come. Next, consider, observe carefully. Consider next B. Okay. Visit of B is 0, right? And B is not in Q. Then NQ B. That is, you add B. Here you have to write separately like this again. A, B. Now your R will be here, F will be at here. Next what you have to do, this is second step what we are doing. Next what you have to do, B is over. Next you consider C. That is C also you consider. Consider C. Visit of C is 1. Or you can write 1 like that. Sorry, 1. No need to NQ. No need to NQ. Next, consider, in exam you have to write like this. Consider D. Now, visit of D is 0. Right? If it is 0 and D is not in Q. Then what you have to do? NQ. Are you getting what I am doing? Huh? Everyone? Right. 1 minute. Yeah. Now what you have to do? You have to write NQ D into Q. That is A, B, D. Right? Now what is, where is R? 0, 1, 2. R is here and F is year. Am I right? Now next what you have to do, consider E. Now visit of E is 0, or you can write like this, 0, and E is not in Q, right? Then NQ E. Now A, B, D, E. Now 0, 1, 2, 3. R will be here, F will be here. Next, what you have to do? Getting? Now all the, you have to write like this, all the adjacent vertices from C is completed. Third step. Next, now delete or DQ the first vertex in Q, that is A. Like that only you have to take A, that is, now C is there, A will come like this, yeah, A, everyone, A. Now what you have to do, A, what after taking this, the A, visit of A is 1, you have to make that 1, that is important. After making that as 1, C is already 1. After making that, then what you have to do, consider the adjacent vertices of A. What are those for A? That is B, C and E, right? According to the order, if you consider B, C and E. Now what you have to do? Now consider first, consider B. The visit of B is 0, first condition is true, and B is already there in Q, like that only you have to write Q, right? We can't add vertex, same vertex again. Then discard B. Next, consider C, same thing you have to write. Next, consider C is already visited, right? It's 1, so discard that. Next, E is already in a queue, don't consider that. Like that you have to write. Now third step is over. What is the fourth step? Fourth step is again you consider the queue. Now what will be there in a queue here? That is important. What will be there in a queue? Now in a queue, B, D, E will be there, 0, 1, 2, R will be here and F will be here. Now what you have to do? Take out B. There you have to show A, like taking out here. Like this. Show like this. This will be good. F and R. Otherwise you can make here 0 or you can make here 1, whatever you want according to that. Now take out B. Now what you have to do? Here you should take B. Now delete or DQ the first element, that is B. You take out B. From B you make first B visited as 1. Right? Now how you are going to take this, I will write a graph here. See, A, and then B will be like this. Yeah, B will be like this. Right. Now take out B. After taking out B, you make this visits as 1. Now from B, what are the adjacents you check? From B, what are the adjacents? Now, adjacents are A, next B itself is there, you don't take anyway, C, and then D. Now all are there in a queue already. A is already visited, C is already visited, and D is there already in a queue. So again you will leave all these things. Then what you are going to do in a fifth step, you are going to take again D. 1 minute. Yeah, in fifth step, take D.
We are deleting node.
Hmm.
Sir, we are taking that node as the source node. Then we are taking the adjacent nodes from
Yes, yes. Correct. The first element of the queue will be the source node again. From there, all adjacents will take. Any adjacents not visited, not in a queue means again we will add to the queue. Correct. I will show. You will get now 5. Now from 5, you consider a present queue. What is a present queue? Present queue is D, E are only there. Right? F and R. Now what you have to do? You should consider D. After considering D, visit of D will be 1. You should make that. Now how your graph will look? B, A, D. Now 1, 1, 1, 1. Visited, we have made 1. Then what you have to do? Consider the adjacent vertices of D. What are the adjacent vertices of D? B, C, and then G, F. Correct? No? Now first you take B. First consider B. You have to do like that. Consider B.
Sir,
Ah,
sir, it is showing in the same paper. Sir.
sorry. Yeah. Now consider B. You can't see. Yeah. I'll rewrite this step number 5. Right? Yeah, step number 5. The next thing in a queue, the queue will be like this, that is D and E. Now F will be here, R will be here. The first element will be D, 0 and 1. Now what you have to do? First DQ or delete D from the queue. Consider D. Now you make visit of D is equal to 1. Now how your graph will look? A, B and D. Now everything are coming from C. 1, 1, 1, 1. You have made. Now then what you have to do? Consider the adjacent vertices of D, that is B comma C comma G comma F. Correct? No? Now consider, you have to write like that. Consider B. Visited of B is already 1. Discard. Are you getting? Discard. That is next. Consider C. Visited is already 1. Discard. Next. Observe carefully now. Consider G. Visited is 0. G is not there in a queue. That you have to keep in your mind. That is very much important. G is not there in a queue. If G is not there in a queue, see here. Visited of G is 0 and G is not in queue. Then what you have to do?
Sir, if you need to take symmetric, then you need to consider vertex G first, vertex F first, and then G.
Oh, I am not taken symmetrically. Yeah, F only you take, not a problem. F only you take. E, F, G, H. Correct. Right. Not a problem. F only you take. Visit of F is 0 and F is not in a queue. Am I right? That means NQ, F to Q. Now, how we have to do? This is important now. Take this and E will be at front. Now F you have to NQ. Your R will be at here. That is important. This is important. Afterwards, what you have to do? Consider next G. Visited of G is 0 and G is not in Q. Same. NQ G to Q. That is, now your Q will be like this. E, F, G. 0, 1, 2. Your R will be here and F will be here. Am I right? This is your fifth step. Go to again sixth step. That is important. Go to again sixth step. If you take big graph, it will take time. That's why. Then go to the sixth step. That is step 6. Now, how is your Q now? First you have to take Q. E, F, G. 1, 2, F will be there. R. Now what you have to do? DQ or delete. DQ or delete the first element in a Q. What is that? That is E. Now visit of E will be 1. First you have to make that. Then graph. Write graph also. Now from C it's gone. A, B, D. But due to D, A, B, C, D, am I right? D. And then you are considering E. 1 minute. Now you consider D. Right. Now consider E, which is a main graph I am saying. Where is main graph? Yeah, E. Right. Now you make visits 1. All 1. Now this is your present graph. Now what you have to do? Consider the adjacents of E. What is that adjacents of E in a graph? Main graph. You can see that is A. Next that is C. Then that is G. Now A is already visited, C is already visited, G is already in a Q. Am I right? So everything you are going to discard that. Right? Are you getting? Now E is deleted here. Come to step 7. Come to step 7. Right? Now here what you have to do in a step 7, consider the Q now. Q is F and G, 0 and 1. This is F, this is R. Now consider the first vertex, DQ that is F. So you have DQ'd that. From you make F visited as of F will be 1. Then what you have to do? Write a graph. C, A, B, D, E. From D you have made F, correct? No? Or what is the last vertex which you have taken? E. While doing 1 minute. While doing D you have did that, right? While doing D you have gone with F and G. 1 minute. F. Yeah, you take F. Right? Now F you have taken. For F you find the adjacent vertices. For F, what are the adjacent vertices are there? D and G. So D is already visited here. 1 minute. Yes, D is already visited. Left out is G, but G is there already in a queue. Am I right? So then what you have to do? Discard the G. Go to step 7. Finally, you should consider G. That is G. You should make it as a 1. Now all the elements whatever there in a queue are deleted. Like this, you have to do the first search. So 2 graphs I have shown you. Now I will go with the program. You can see the program. Just stop here. 1 minute. Again, share this, share the window. Yeah, BFS. Share. Now you can see the flow of the program here, how BFS will work. Very simple. See the main program. Main program is first what you are going to take n vertices. Before that queue you are making the initialize to 0. Queue size is almost all 20 and visit of I you are making to 0. That we have did. All vertices initially it will be 0. Queue empty queue will be there. That you have to do. Then you take the adjacent matrix for the graph. That is zeros and ones. You are going to take anyway. You know this, right? Now you take the source vertex or a starting vertex. For example, in first case we have taken A. In second case we have taken C. Now taking that you enter into the function. Now observe the function how simple the program is. For I is equal to 1 starting from a first vertex. For I less than or equal to n. So what we are going to do, we will take a starting vertex if a of vi is 1, that is from source vertex to the other vertex there is a adjacent edge and not visited of I. That means if it is 0, then what we are going to do, we are going to add first pre-increment R, we are going to add that to the queue. Very simple. Like this we are doing. Next, we are checking if f is less than or equal to r. If f is less than or equal to r, what we are going to do? We are going to do visited of. See, for a for loop, after doing all adjacents you are putting into the queue, this is very much important which you have to see. Your for loop is there here. Am I right? For for loop only one statement will be there here. This is important. That you have to take. Only this much. Now what you are going to do, whatever the from source vertex, whatever the adjacency vertex is there, that all adjacency vertex where the visited will be 0 and if the adjacency is there from the source vertex, then you are adding that to the queue, means that vertex to the queue and you are incrementing the r, everyone. Initially f is equal to 0 and r is equal to -1. Same thing we have also did. After doing that, assume for example in the first case what we have did from C we have taken A, B, D and all we have taken, right? So taking all that into the queue, I'll read out the first one starting from C. If you take A, B, C, D, E, all we have taken to the queue. So all will come to queue here according to that. Then what we will do? Then we'll compare f is less than or after this for loop. Keep in your mind, after this for loop, after adding all the adjacents of the source vertex, what we'll do? We'll compare if f is less than or equal to r. Yes, f will be at a starting vertex. That means there are elements in a queue. In r is somewhere, far means there are elements in a queue. Visited. Very important. Visited of q of f is equal to 1. First element we will take and we'll make that visited as 1. Again we'll call that back. Now source vertex will become a queue's first element. Keep in your mind, recursive. Again, source vertex will become a first vertex. Afterwards, increment will be there here of f. Are you getting? Now what is the source vertex? For example, A from C we have taken A, B and D, E, like that we have taken. Next what will be there? A will be there. So taking A as a source vertex, again we'll get inside. From A we'll check all other vertices. That is from A to all other vertices whether adjacency is there. If it is 1, first we'll check. Then afterwards we'll check whether the visited of that corresponding vertex is 0, then only we'll add to queue, otherwise we don't add. This is important. Again what we are going to do, again we'll take the f's first element. F is incremented here, that means f has become 0 to 1. Now next element will be B. Now we'll take B as a source vertex. Now we'll get inside. Like that we are going to do. This is a simple logic what I have did taking a queue into the consideration. This is a simple logic which we are going to do. This in exam, if you write this much, that is enough. Before this, what you have to write? Initialize visited all to 0 and queue to 0. That only you have to do, initialize. Then afterwards, you can write this. How beautiful the algorithm is. See, any doubt is there here, you can ask. Any doubt? Any doubt? Any doubt? Any doubt? Hey, respond, man.
No, sir.
See, I repeat once again. I'll conclude like this. Initially, first user defined source vertex we will take and will come here. From that source vertex, what are all the other vertices is there? If the vertex is adjacent and visit is 0, we'll add to queue. Add to queue. If after adding all, that is very much important, all the adjacent vertices will add to queue. After adding that, then we'll check whether the elements are there in a queue. Before deleting the first element from a queue, we should check that the elements are there in a queue. Yes, there are elements in a queue means how the condition? If f is less than or equal to r, that is the condition. Yes, that is there. Take out the first element and make that visit as 1. Again take that as a source and again enter into the program. Again same procedure you apply. From that all adjacent vertices you take. If it is not visited and there is an adjacent means add to queue. After then what you have to do? Again you should take a first element as a source. Again you should. Same thing we have did in a tracing in a last thing. Right? Got it? Everyone? Yeah. Now this is a birth first search program, and only one is left out, that is prims. I think afternoon you don't have a class. What is there afternoon in extra timetable?
No class.
No class, right? Check it once, please, everyone. In extra timetable you check. Is there?
Yes, sir.
Which class?
Research.
First hour, right?
2 hours.
2 hours, sir.
2 hours ಇದೆಯಾ? ಇಲ್ಲಮ್ಮ 1 hour ಇದೆ ನೋಡಿ. 2 hours. ಸೊ ಆಮೇಲೆ ತಗೊಳ್ಳ ನಾನು 3:45ಗೆ ಮುಗಿಸ್ಬಿಡ್ತೀನಿ ಇವತ್ತು ಅದಕ್ಕೆ.
Okay, sir.
Okay, 3:35 I will take a class until 4:30. So I will complete that prims algorithm. So syllabus will be completed. Right? Friday I will do the revision classes. Okay, pa?
Okay, sir.
Okay, so exactly 3:30 I will take a class for you. Okay?
Okay, sir.
How many are present? 53. What about others? They don't want. Right. Okay. Thank you very much.
Thank you, sir.
Thank you, sir.
Right. ಇದೇನೋ ಆಯ್ತಪ್ಪ. ಲೀವ್. ಸರ್ ಹೇಳಿ ಸರ್, ಹೇಳಿ.
ಸುಮ್ಮನೆ ಹೋಗ್ಬಾರ್ದು ಅಷ್ಟೇ ಸರ್, ಎಲ್ಲ ಕಾಂಪ್ರಮೈಸ್ ಆಗಲಿ ಬಂದಿರುತ್ತೆ
ಹಾಂ
ಪೇರೆಂಟ್ಸ್
ಅಲ್ಲ, ನನಗೆ ಇವರು ಫೋನ್ ಮಾಡಿದ್ರು, ಯಾರು ವೈಸ್ ಪ್ರಿನ್ಸಿಪಲ್ ಸರ್.
ನಾನು